Let me tell you a little bit about myself first. I am a software engineer and have been working with code since 2009, roughly. I am mostly a front-end engineer, but I have occasionally dabbled with Node.js, so I guess I'm sort of full stack sometimes. Nowadays, I split my time between coding and really fun things and also managing my team remotely in San Francisco. So I work for a company called Make School. Make School's product college program is a computer science program for students in mainly the United States. And basically what's so special about it is that there's no upfront tuition. I guess, especially if you know about the US education model, you know it's really expensive to study in the US. So we've been fairly popular because of this new model, where basically the only time a student is going to pay tuition is after they graduate, if and only if they find a job. And so, yeah. The other thing, this is gonna be obligatory. Obviously, I like cats. I mean, come on. Like I said, I am a front-end engineer, so I feel like it's just kind of a given. This is my own cat. And what I do in my spare time is obviously spend time with her. And I really think my talk was selected because I put a cat in there. And I promised cats, so here it is. I also feel really passionate about zero waste. And so if you're interested about zero waste, especially in Montreal, talk to me after, and I'll tell you a little bit more what that's like. So what will I talk about today? Obviously, REST APIs. What do they do? What did they do? What can they do still? The problems that come with it, and then how GraphQL can solve them. GraphQL is a query language that was developed by Facebook, and I'll show you how it works and what you can do with it and how to solve problems that come when you use REST. Of course, the most important part, lessons learned. I've been working with GraphQL for the past 3 years, basically since its inception almost. And there are a lot of pain points we've encountered along the way. And I want to share with you what we've learned from them. I'll also introduce a few tools that work really well with GraphQL. So, once upon a time, no, I'm just kidding. We're not going back that far. There will be some story time later in Q&A. But actually, let's just go back 3 years. 3 years ago, I had just started working at Make School, the company that I just presented. And around the same time, Facebook actually presented GraphQL and React for the first time on the world stage. They were these really new technologies. And if you work on the front end, you know, maybe this is actually the same on the back end, but on the front end, I feel like it's especially like this. When there's anything new, everybody's like, oh my God, we need to do this. And there's React and Vue.js and all these like new shiny things, and suddenly everybody's really crazy about these technologies. And well, when I started working at Make School, we were basically thinking about building this new product. And as I said, we are a software engineering school, so we teach fairly new technologies to our students. And when we were debating what technology we should use to implement this new product, we basically decided that we should go with the most cutting-edge technologies, regardless of the fact that documentation is kind of sparse and that might not be the accepted standard yet, and possibly it's not going to survive the first year. But hey, we were basically, like I said, super cutting edge. That's what we decided to do. So we just dove right in and built a product using React and GraphQL. So what that means is basically our tech stack became Ruby on Rails on the back end. You know Ruby on Rails? Yay! And until then, our front end was actually also completely done with Ruby on Rails. So it was like a fairly static pages with HTML and CSS and some amazing jQuery thrown in for good measure. And our new product was supposed to be better. And so we decided to pick up React as one of the main technologies on the front end. So we built the standalone product with React on the front end. And then to connect the pieces, we used GraphQL and Relay Classic to basically pipe the data from our backend server into our new React front end. And we also still, and have back then, used a little bit of REST. So not to preempt the talk, but after 3 years of working with GraphQL, I am a GraphQL believer. Yes. This one, I'm a believer. I'm a GraphQL believer. This one's for Canada. We're in Canada, so here we go. After 3 years, I confidently can say that I really, really like working with GraphQL, and I want to share with you why. So let's rewind just a little bit. Back in 2000, the API standard of REST was basically released when Roy Fielding came up with it in his PhD thesis, because everybody just does that. And it basically became the standard. It quickly was adopted by all of the technologies that basically had to deal with data. And this protocol was suddenly the best way to share data. So to talk you a little bit through how REST fetches data, I want to present to you a UI component. I'm going to talk about one of the components that we have at Make School, which is a dashboard for the user, which basically is, because we are a school, we have a learning management system that helps our students understand the content in their classes. Our instructors put content onto the dashboard, and then students can consume it. And then obviously the most important thing for our instructors is to be able to track progress, but this is also equally important for the students because they want to see how fast they are along the, not how fast, but how far along they have progressed. So here's our dashboard. At the top, we have the name of our track, then we have the progress for the entire track, and then and I'm sort of jumping ahead, sorry. But yeah, so here we go. There's our dashboard. It's the enter point, and one of the things, it's each dashboard for each user obviously has slightly different data because it depends on how far a user has come and which track they have chosen. Then we want to track progress, and obviously that varies from user to user depending on how far along they are. And then most importantly, we have our lessons. The lessons actually break into individual chapters, and they also have a little completion status. So that users know right from when they get into the dashboard if they have completed their chapter or not. So how do we get data into this? So with REST, we get reusable endpoints, and that basically means that we can just use them to get data from the backend and then pipe it into the front end. For our example of the dashboard, let me just show you if we were to use true REST API calls, how that could look like. So here's our dashboard. We fetch it by the user's ID, and things that could be in there is things like settings that a user has basically chosen, and obviously every time they come back, we want to persist those. We also want to get the tracks by ID and also share the progress. We're doing the calculation of the progress on the back end because a student could potentially have a lot of tracks, and it could be really intensive on the front end. And last but not least, we're getting tracks, and within it, the lessons that are in it, and the completion state. So if we were to go with true REST, that could potentially mean that we would have one API call, and with it, we get one data set. This works, and has obviously since REST was first established. However, one of the problems with it is that with the example that we've just done, we could have 4 round trips going back, requesting data, receiving data, and that could, be bad. So let's rewind a little bit. Why did REST get adopted if it is this bad? Well, back in the day, users were exclusively on desktops with LAN connections, and the newly accepted REST standards basically swept up the tech world because it wasn't a problem to have people on different devices over different kinds of data transfers. Yeah, over Wi-Fi, let's put it that way. However, fast forward, remember 2007? That's when Harry Potter's last book was published. Huh? Isn't that good? This is really important. No, obviously this is not really relevant here. What's important is the iPhone. The iPhone came along in 2007 and basically started the smartphone revolution. I imagine all of you have one. And so let's fast forward to today. Today, our users, or I think anyone's users, are on their smartphones all the time, and they have all of these, they have this little tiny powerful computer in their pocket, and that is what they use to go to your website. Our students are from the millennial generation, and so they practically live on their phones. So there are several problems that we're facing here. Having to make REST calls with too much data takes a big toll on their data plan, obviously. Having to make too many REST calls with smaller data sets is also really problematic because browsers only accept a limit of concurrent HTTP requests. So we basically have to wait for the page to load because you can only make so many requests at a time. Remember, every single image that you have on your website needs to be downloaded in a single request, coming back. Oh, and let's not forget, there's 3 other API calls that also need to basically be somehow accommodated. We need to add data, change data, delete it. Every single action with REST needs to have its own API call. So if we were going to, for example, Ruby on Rails, one of the ways that it shines is that one database model can have up to 4 API calls, even more if you want to go into specifics. But because that's every single traditional REST API call responds to a CRUD action on the database. So you can imagine that for each model, especially in a complex application, you can have potentially tens or hundreds of API calls. So obviously, the example that I mentioned before is not really how we do things. So what we really do is we optimize REST calls, right? You will develop your API so that each API call makes sense and things are grouped logically together so that they basically fulfill the endpoint for the front end that, the front end needs data. So if we go back to our dashboard, so our API call is all the stuff that we need in a perfect API call, and we're done. OK, now I can go home. However, as we've heard in the previous call, that's not how it works. In the previous talk, sorry, that's not how it works, right? Because in the real world, we have our perfect API call, but then you have your product manager and your designer and your users, and they all come up with all these amazing features. And so what happens? Well, our perfect dashboard with our perfect API call quickly becomes out of sync. And so what we'll do is we make a new API call. So we create a new custom endpoint with a new data set, and then we're done. Well, another feature comes up, and another feature comes up, and you know how it goes, right? Soon you'll be in endpoint hell. So in a perfect world where nothing ever changes, REST would be pretty fantastic and really organized. But the reality is that on the front end, things will always change. It's just the rule. That's the mantra. And there will always be new features which require new data. And so we will need the backend to provide us with this new data. So we'll just keep going on and on. A solution has been to release new API versions over time. And then basically, we've got these messages every time you work with an API that basically the next API from your favorite provider is basically ready to be upgraded. And so as a front-end developer, what that means is you spend some time migrating to the next greatest version, and then a year later, there's the next API because they obviously added new features, and you want those new features. Until now, this has been the bane of our existence. Obviously, let's sum it up. Problems that we have with REST are you are tied to the backend, and the backend decides what data set you are retrieving based on the endpoint that you are requesting. Having one API call, you'll probably end up requesting a much larger data set than you actually need. In our example, you probably get all of the data for a single lesson, all of the content, even though all the things that you need on the dashboard is really just the name of the lesson and maybe the name of the individual chapters. Another problem is underfetching. You might not get enough data because the endpoint that you requested is basically giving you some of the data that you need, but you've decided that you want to pull something in from another object. So you basically have to do a second API call to another endpoint. And basically that means you request to multiple places and your site will be slower because, like I said, browsers can only support concurrent requests up to a limit. It's slightly different from browser to browser, but I think the maximum right now is 18 concurrent requests with Chrome, possibly. And then obviously our favorite thing, refactoring. Of course we can refactor. If it was up to the engineers, we would refactor all the time because it's amazing. But in an actual real-world business, refactoring isn't always desired because to your product manager, it doesn't add obvious business value, right? So you basically have to convince them, so can we spend a little bit of time on refactoring because that would make it so much better. So most likely you'll get a no because features are way more important. So instead, you build on top of what you already have and you end up with a big and messy code base with lots of duplicated stuff possibly, and you're gonna be unhappy. But it really doesn't have to be like that because GraphQL to the rescue. The reason why we're all here. So let me tell you a little bit about GraphQL. Huh? What? So GraphQL is a query language for your APIs. What's most important is that it is not actually an API itself, and it is also not a framework. It's a query language, and it can become the link between your front end and your back end. And the reason why I'm really excited about it is because the syntax that it uses is so easy to understand, and it allows you to get really predictable results. But I don't really want to convince you. I'm just going to show you what it looks like. So, recognize this? Does this look familiar? This is Jason. I imagine most of you know Jason. He's my best friend. But basically, this is the result that I'm getting back from the GraphQL. You know this from REST. Like, it's what you get if you make a REST call. So this is very familiar to you. And nothing's changed so far. The magic happens in the request. So this is a GraphQL request. This is what I put on my client to get data back from the backend. Look at the syntax. It is super easy to understand. It's basically JSON minus the colon and the values. So you basically just have the keys, and the only thing that's new is that we put the little query at the front to distinguish what this is. And I'll explain a bit more why we need to do that later. But yeah, this is it. Like, the syntax is super easy to understand, and with the query at the beginning, GraphQL understands how to interpret the results on the back end. So where do we put this? So remember how REST has the get endpoint? Well, GraphQL's endpoint, its one and only endpoint, is called execute. And all of the data that is requested gets fired to it. It will respond with a JSON object, just like the one that I just showed you. And your client has defined all of the data that it needs. And the backend returned what the clients requested. This means that even apps on a mobile phone can be super quick because there's only one endpoint you can go to request data, and you get all of the data that you need. And yeah, now I can go home because this is all you need. Yeah, so this is super exciting, and I definitely have more to share, but that's basically all you need to get started with GraphQL. So yeah, it's done. It's good. Like, we're done. One endpoint, and you got it all. No, there are obviously more things that I have to share. One of the really cool things in GraphQL, like amazing, is fragments. If you've worked with front-end code before, you know that currently the move is towards components. Everything should be a component that is reusable. And everything that can be a standalone component really should be a standalone component. And GraphQL makes it super easy to work with it and define the data that you need for your front-end components. So let me show you with the previous example of our dashboard how we can structure our components and fragments with the help of GraphQL. So here's our dashboard. Remember the track progress at the top, then we have our lessons, and I added one more component, which is the pink one. That's the chapter. Using React, we would most likely have one entry point into the application, which is the dashboard in green. And then we have the track progress component in orange, where we would use one fragment. And then we have the lessons, which would be another component, which would have another fragment. And then we have the chapters, which is the smallest component. Let's call it a leaf. And basically, that would be its own fragment. So if we start with our very smallest component, because it has the least data, we could basically fetch data like this. So we say, OK, there's our fragment. Again, note the pink fragment at the beginning, which is a specific GraphQL syntax. And then we say, OK, we want to fetch chapter on something called an edge. And our edge here is chapters. And inside of that, all we need to display it on our dashboard, let me go back one, is the name of the chapter and whether it is completed or not. And that is all I'm asking for. Here's the name and the completed, give that to me, and that's it. If we go up one level into the parent of the chapter, that's our lesson. The lesson basically needed a name at the top, and then it consists basically of its chapters, right? Because we already defined the chapter inside the chapter fragment inside the chapter component, we don't have to do it again. We can just do ... chapter, and GraphQL will make sure that it can, that they belong together. So this is awesome on the front end because it means that our components know exactly what data they need, and then that is how we basically requesting it from the back end. So you might now wonder, oh no, all these fragments, that means we have to have multiple API calls. Well, haha, fear not. The power of GraphQL reveals itself. So the way it works is we have all these individual fragments. And like I said, let's say the chapter is the smallest one, and then that fits into the fragment of the lesson, which fits into the dashboard. And then we have another fragment for the progress, and then that goes into the query. And then that gets fired off to the backend. Behind the scenes, what GraphQL basically does is it takes all of these fragments and it deduplicates the data that we have requested twice from, let's say, we need the name of the chapter twice on two different things. It deduplicates it and only requests it one time. And then it sends off the data to its one and only endpoint, execute. So a few more things GraphQL can do that I want to introduce you to are variables. Yay! I'm sure you're all not full at the moment because we just had delicious lunch. But in most applications, what we want to do is pass along some variables based on a user's choice, for example. You know the drop-downs where you choose something, and then based on your choice, the second drop-down populates. In this example, one of the things we would or could do is retrieve incomplete chapters. So the way we could do this is like this. So we have our fragment, chapter on chapters, you're familiar with this. And then one of the parameters that you can pass along is basically, OK, I only want to have chapters true, a completed chapter true or false, based on a variable that we defined in our code. I mean, this is a really simple example. I know that. But basically, this is one simple way where you could basically define that you only want to retrieve the incompleted chapters because, let's say, you users are on a mobile phone. I mean, unless they specifically request that they want to view the completed chapters, they're most likely more interested in the incomplete ones because they want to continue their work. Another concept is directives. So sometimes instead of passing variables along, what we really want to do is change the structure of our data altogether based on a user state, for example. Imagine we are back on our dashboard. Note that the top one is open and the bottom one is closed. So why request the chapters for the closed lesson if, the user is not even going to see it? So one of the things we can do is only request the chapters for the lesson that is open. And one of the things that you can do is basically add include is one of the directives that GraphQL supports. Add include if that is true or false. And once again, this is defined in our code. Again, I realize this is a very simple example, but basically, I think it's a good one. And the add include directive can be really powerful to save your users from having to download data that they probably are not going to look at. GraphQL has 2 directives, so they're really easy to remember, and I think they're super self-explanatory. The first one is add include, which basically takes a Boolean and, well, it includes data if you say, put it in there. And then we have add skip, which does what it says. It skips the data set if you say that based on the data set, you don't want it. And then our last and most interesting GraphQL mutations. Okay, so now we've replaced the REST GET request. But you might wonder, oh, what about all the other REST API calls? Well, there's post and put and delete and a bunch of others, patch, I guess, and I'm sure there are more. And GraphQL obviously can do all of these as well. But like I said, there's only one endpoint in GraphQL, and that is execute. So what it uses instead are mutations. Mutations replace all of the other REST API calls that mutate or modify data. So let me show you what a mutation could be. So back on our dashboard, remember we had the smallest chapter, and it can be completed or not. Obviously, it is the user's action to basically say, oh, I've completed this chapter, I'm done. So for our users to be able to mark a chapter as complete, we need them to be able to click a button or something. And that, in turn, fires a mutation. So in this case, again, note the mutation at the front. So that is the second root type that GraphQL has. So there's a query, and there's a mutation. And I tell you a bit about it on the next slide. And basically, the syntax is verb noun. What does it do, and what does it do it to? And then inside of it, and that's obviously up to the developers, but that's current best practice. And then you pass in the parameter of what it is that you want to change. So in our case, we just want to say, OK, completed is true, so mark this off. And obviously, this can be a toggleable function. Yeah, I don't think that's a word. But basically, you can toggle that function and obviously pass in false if you want to undo that the student has completed it. As you can see, the syntax is exactly the same syntax that we had with our query. So there's nothing new to learn here other than the fact that you need to pass it along as a mutation root type as opposed to a query root type. GraphQL has exactly 2 root types. Basically, that means that is the most top-level access point of GraphQL. When your request goes to the database, it's the top-level entry point at which it starts to look for data. Mutations and queries live side by side at the root level of the GraphQL object. So just to put a little table in here, basically, just to recap, we have queries which fire off to execute, which replace our GET request. And then we have mutations which also fire off to execute, and they replace pretty much all of the other REST API calls that are mutating any data. Tools. Okay. So one of the tools that we've been working with at Make School extensively, and hate love, is Relay. Relay is a JavaScript framework for building data-driven React applications that are powered by GraphQL. It has standardized formats on how to set up your queries and mutations, and the query setup is fairly straightforward. But the mutations, oh my God, they get me every single time. That's because the documentation is still kind of weird. Let's just put it that way. I don't want to find any controversies later. But yeah, they talk about Star Wars battleships. That's their documentation. I'm going to show you an example in a second. And every single time I have to work with mutations, I have to read the documentation again. I mean, it's been 3 years, but still. GraphQL is amazing, but Relay can be hard. Let's just put it this way. So what is Relay exactly? Relay couples React with GraphQL, and it develops the idea of encapsulation even further. Of course, it's possible to use React in GraphQL without Relay, but Relay was made for GraphQL and React by Facebook, and together, the 3 of them are a match made in heaven. Relay is really what brings GraphQL and React together. You would have to reinvent the wheel and write a lot of the functionality like cache management, responsiveness, and dealing with failure yourself if you went down that path. One of the things that cache, for example, can do for you is check that you already have data from the previous requests and not request it again, which optimizes subsequent queries even more. And then there's Apollo. It's a platform that is also supposed to make development with React, Relay, and GraphQL easy. I haven't tried it myself, so I just know about it. But apparently, it makes it easier to ramp up with GraphQL, and so good luck. But here's my favorite. It's amazing. I know this one might not look like a lot, but GraphQL, that's how it's pronounced because it has an I in there, note that, is amazing. It makes everything about GraphQL like even more amazing. It's already really good until this point, but GraphQL basically helps with developing. It allows you to visualize what's in your data, like what's in your GraphQL, what you can pull out. You can see inputs and outputs. You can even pass variables along. You can see types that belong to it. It's basically a self-documenting, I'm not allowed to call it an API, query language. So this GIF is off their official website, but like if you have to start working with GraphQL makes it so easy and so fun, you're gonna love it. And you don't have to, write the documentation side by side, which, is one of the things that we discussed in a previous talk, I think, where documentation gets quickly out of date. It can't with GRAPHIOL because it's basically built into building a GraphQL on the back end. It's amazing. You will love it. So, lessons learned. One of the things that has been really difficult in the past 3 years is that documentation is either difficult to understand or incomplete. I want to say terrible, but I'm probably not allowed to do that. And in the last 3 years, especially at the beginning of 2015, oftentimes we found ourselves just guessing how we should be doing things because either we couldn't find the documentation or we didn't get it or there wasn't any. Based on the previous experience that we had all as developers, we basically just implemented it to the best of our ability and hoped for the best. And well, let me tell you, it was an interesting ride. But I promised you some fun documentation, so here's one. Destroy ship mutation. I mean, that's just totally logical, right? It makes total sense. So this is basically how Relay was trying to explain how you can remove a node or an edge inside your data. And I have to say, for this talk, it took me a while to track this down because in their defense, they have updated their documentation and now they talk about really boring things like to-do apps and how do you like your friend's stuff and this is the mutation that you need to like your friend's stuff. So, okay, good on them. They've updated their mutation, they have updated their documentation, and with Relay Modern, the documentation is actually not that bad anymore. But, oh my God. If there's one takeaway that I want you to have from this whole talk, is this one. Embrace fragments. 3 years ago, when I started working with GraphQL, like I said, I didn't really know what I was doing, and what basically happened was this. We had this dashboard, and all of the data that I queried was in my entry file. It was so long, because every time we built a new component, I basically had to open my dashboard file and then add this new data that I wanted, because I think it was an oversight. I'm not really sure what happened with the fragments, but we didn't know about it for a while. And so we had these really long entry files for GraphQL. And since then, obviously, it's a long time ago, we've come around. And nowadays, we've refactored it sufficiently enough that we almost have them all in fragments, I think. I want to say almost 100%, but that might be a lie. But what you should do if you start out with GraphQL for the first time is embrace fragments and make it basically every single component that has data in it should have its own fragment. It is what makes GraphQL so special, and it is what allows for the power of encapsulation. So we should really make the most of it. Relay is hard. It's really hard. Our biggest hurdle was, and sometimes still is, relay. It is the piece connecting GraphQL and React, though, and it has some really non-intuitive parts to figure out. But it is important, and it is one of the technologies that really make it all fit together. So sort of embrace it. I know it has a steep learning curve, but it will get better after 3 years or so. One of the things that is also still true to this day is that even now, there are still few best practices. I guess 3 years is still fairly new in the tech world, and the documentation is improving. But if you have really tricky parts in your app, there's most likely not a standard yet. Which means that every dev team out there is still kind of working on trying to figure things out. But the community is really awesome, and it is quite easy to ask for help. There are various channels to do so. But you might not get any help because there might not be an answer. So, but you can actually help, shape best practices. So it might not be such a bad thing. So you might think that after all of this, I'm telling you, ditch REST, go for GraphQL, it's amazing. And it is the magical solution to all of your problems. That is not the case. It's not what I wanted to say. If you got that impression, I'm sorry. But GraphQL is not exactly a replacement for REST. It does a lot of great things well, like data fetching and manipulating, but there's also a few things that it can't do, or actually, it wasn't designed to do them. One of those is authentication. It doesn't do it out of the box, and it's actually encouraged not to use GraphQL for authentication. I haven't seen anyone use GraphQL for authentication in production, at least not as of yesterday. So I still hope this is true today. But which, it's changing so fast, it's like impossible to keep up. But it is perfectly fine to use your authentication using REST and then fetch and modify your data using GraphQL. Remember I said that we use GraphQL extensively, but we still have REST. That's because for authentication, it is still the best standard out there. And actually, if you think about it from a security standpoint, it's actually quite desirable to have authentication on one sort of way to authenticate, and then fetch data with a different technology. My favorite, no refactoring. I mean, I know I said I love refactoring, and I do, but if the alternative is that everything is great without refactoring, then obviously I'll take that. In the past 3 years, we did so much refactoring on the back end. And of course, like I said, on the front end, it's just inevitable because users, product managers, everything, life, you basically want to add new features, you want to update old ones. Refactoring is a part of our lives as engineers. And, we love it, like I said. But one of the reasons for why I wanted to give this talk in the first place is because over the years, with all the refactoring on the front end and on the back end, the one constant in our code base has been GraphQL. Fields have been added to our GraphQL, which basically gives us more data, but we haven't removed anything. Also, the endpoint never changes. Like, you always go to the exact same endpoint, and then suddenly you have new data on it, and you can see it in GraphQL when you open it because, look at that, new things. So basically, versioning with GraphQL is as easy or as simple as exposing or deprecating a new field. GraphQL is the future. So even though there are some cons, I get that. As we've said I think in the previous talk as well. Everything was in the previous talk. There are obviously some drawbacks with new tech. There always are. But the pros far outweigh the cons, in my opinion. All the things that GraphQL can do better than REST make it a really outstanding technology to pick up. And even if I said the learning curve with Relay is really steep, the benefits of GraphQL for data fetching and modifying over REST are really encouraging, and the community support around it, and Facebook owns it, so it's amazing, means that GraphQL is around to stay. Like I said, it's 3 years old. Documentation is, even though it's gotten loads better, there are still tons of open questions that need to be answered. There's a really cool channel on Slack, of course, everything is on Slack, where you can basically, this is to sign up, where you can basically talk to the people that either help shape GraphQL or have frameworks related to GraphQL, like Ruby GraphQL or GraphQL Ruby. Oh. One or the other way. I think it's Ruby GraphQL. It's basically out there. And one of the things, if you are interested in picking up GraphQL, that I would ask of you is to help by participating on the channel. And there's obviously always Stack Overflow, but it's not as concise as Slack, where it's dedicated to a single technology. Help us figure out best standards and practices by using it in your code and answer questions that basically are still out there. So if all of the things that I've just told you didn't convince you to pick up GraphQL yourself, you can do it for yourself. Go out there, do it for the learning experience, because that's what engineering is all about, really. Come on. And pick it up, convince yourself. Here are some really cool places to get started. How to GraphQL is amazing. It allows you to basically check out the technology that you're interested in. Let's say you want to use Ruby on the back end. It helps you basically build a Ruby app and then use GraphQL, build a GraphQL schema, which basically defines which fields you want to expose on the back end, and then have a small, simple to-do app on the front end so you can sort of see what the interaction is between them. And then, of course, if you can't get enough, there's graphql.org/community, which is insane. It is literally a giant list with anything that anyone has ever published about GraphQL. So if you want to go crazy, that's the place to go. Thank you. Any questions? Yeah.
So I know that.
Oh, sorry. I was pointing at her. Oh, sorry. Yeah, that's a good question. Yes, we've basically, I wouldn't say that we've solved them. We have a solution, and it works for us. But the thing is that we are not 100% sure if it's the right solution. So we've actually started talking with other companies at the moment, not companies, but people on the GraphQL Slack channel to sort of see if there is a sort of standard and best practice. And there's actually several things where we are not 100% sure we're doing it right. One of the main things is mutations, because it's sort of a complex thing with, getting data is easy, I think, but basically updating the data, especially with edges and node and in which manner you have to do it, we are fudging it, I guess, sort of. Like, it works, let's just put it this way, but it feels like every time we have to work with the next mutation, we are sort of lost to like, oh, is this the right way to respond the data set? And then a second problem that we've been talking about also in a group with other developers is errors. So when something happens where the user has not the right information, or the database, like the logic on the back end, basically can't compute it correctly, the way that errors get returned to the front end so that you can give a useful error to the user is still not documented very well. Yeah, like actually, I think there might be no documentation about it. And so we are winging it, and often on the front end, what we end up doing, because the back end doesn't really give us useful information, is to just assume that something's failed and then have a very generic, something went wrong, please refresh the page, which obviously is not ideal, but it's the best we have at the moment. So yeah, errors is, I think, a big one. You had your hand up?
So I can see that we have relay in the front end, so tie in React and GraphQL.
Mm-hmm.
But we still have the database and GraphQL sitting in front of it.
That's right.
So where do we define a schema that tells GraphQL what to fetch from the database?
Good question, yeah. So basically, I mean, I'm a front-end engineer, but I do know that part actually a little bit because it's become something that seems to be frequently forgotten to be committed, and then someone else has to run the schema. But basically, the way it works is that, like you said, GraphQL sits in front of the database, and it has its own schema. It's called the GraphQL schema. And basically, when you decide that one of the fields on your database should be exposed, you put them into the schema, and then the front end can access them. That's another good one that is actually one of the other non-clearly defined standards. So permissions at the moment, the way that we do it on our side, and is again a question mark, we're not sure we're doing it right. We have a special file in our code base called a policy where we declare, you know, who has the right to get that data back. So in that policy, we say, oh, if this is an admin user, they can get it, and if they're not an admin, they can't get this data set. But the problem is that we haven't been able to find anyone else do it that way. So we've been reaching out on the GraphQL community to see how other people are doing it. And basically, the latest release of the Ruby GraphQL gem seems to suggest that permissions are actually handled within the schema and the types where you basically declare what object can be returned. But like I said, there, again, isn't a clear standard. So it's sort of also a question mark. Yeah.
I worked on a project which had 3 different APIs, 2 that were REST, one that was GraphQL, and GraphQL one was used later, so we already had a structure with Redux and all of that. So we decided to just wing it and use any basically REST to call GraphQL, and it's a mess.
Oh, sounds interesting. Okay.
Yeah, and my question is, do you have any idea if Redux and Relay or Apple can be mixed together? Because what if you have some calls that don't need GraphQL or Relay and have some other parts that do? I have trouble seeing completely refactoring our whole Redux logic to Relay.
Yeah. So we actually also have a mix of all of the above. So what we do is, I'm trying to think actually. So we use GraphQL. And so, for example, one of the good places where we use Redux, even though we use GraphQL, is errors for the front end. So we have a little banner at the bottom, and when something goes wrong, it pops up and tells you something went wrong. And Redux is really good for that. So what we did is we wrapped our entire React application, like one of the entry points, into a wrapper, which basically connects to Redux so that we can then trigger out an error for any of the views. And inside of the individual components, we still fetch data from GraphQL. So, and for authentication, we still use REST. But the thing is that because it's Ruby on Rails, it's a little bit more complicated because it's not a standard REST API call. It's like, how Ruby on Rails has magic in the box. So it's kind of like that. But then we do have React applications which do straight out REST API calls because we were trying to test the waters on if it actually is better than GraphQL. But now looking back, because we have to refactor that component, we actually also need to refactor the API call because we've decided, oh, we want to have new features on this particular component. And obviously, the backend API call doesn't support it. And so looking back, we're like, oh, why did we even think for a second that REST would have been a good idea here, even though we already knew GraphQL? So yeah, I feel like when you are working with legacy code, then basically the problem is that moving over to GraphQL could potentially mean that you end up with this weird REST GraphQL connection. But I think maybe somebody needs to just make a clear decision on be like, no, it's GraphQL now, and we're not going to do REST anymore. And I think it sounds like in your case, there might be a small issue of having to refactor it to be all the way on GraphQL.
Our issues that we have two different, like,
Yeah.
people. Like, we had the rewards API and the online order API. They were coming from two different companies, so we couldn't actually. So that's a little trickier.
Yeah. I mean, yeah, I think that, yeah, it sounds like technical debt, where I guess it depends on if you want to go REST all the way or if you want to do GraphQL all the way. I think that there's really good reasons for why you would use REST only for authentication, for example, and then really move towards GraphQL. And, you know, if you do the GraphQL way, it actually will speed up your applications, which obviously is always a big win. Yeah. Any more questions?
We selected different speakers, so they submitted speakers. And Alena actually submitted 2 talks. One that was technical, the one we're having now, and the other that was more soft skills oriented about digital nomadism. And Alena is actually managing
Yes.
in San Francisco while she lives in Montreal.
Yes.
And I think you could tell us just a bit quickly about this. Organize your day, and also you traveled around the world and you were still programming. So how did you organize, basically?
Yeah, it's a good.
So
like now I just have to wing my second talk. Yes. Okay. Well, basically, like I said, I work for a company in San Francisco while living in Montreal nowadays, and I had the engineering team there. From here, it was more coincidence that I ended up in that role, but I actually really enjoy being a manager nowadays. Because we're fairly small, we're, like I said, at just a small college that is sort of starting out, I also still code. And mainly because when I don't, I really miss it. And I feel less productive being a manager than being a coder. I don't know, it's something in my head. I need to get over it, I've been told. But I really enjoy coding. And basically, I found them because I wanted to move to San Francisco. But it's complicated, you know, with the visas and everything. So I decided to come to Canada instead. And while I sort of was looking into moving to San Francisco, I traveled through Asia and still worked for them, which is easy when you are just a coder because you don't have as many meetings. When you become a manager, it's a bit more complicated, but if you are in the same time zones, you can make it happen. But also when you travel, you don't have cats. This is my main reason for not traveling as much at the moment. And yeah, my day is basically hanging out with my cat in my living room and sort of, yeah, coding, having meetings. And because time zone differences, I have my mornings to code and my afternoons for meetings.
Thank you.
Thanks.